Is a new experiment called pulse position modulation. So pulse position modulation is generally, there are two sections will be there. It is nothing but very simple concepts. We need two multi-vibrators, that's all. So one of the multi-vibrator is called as an A-stable multi-vibrator, the first section, where we are going to make a constant triggering pulses. That is, we will consider as a carrier signal. These carrier signal will be modulated by using a modulating signal. So I will explain this practically by showing that our trainer kit here. Okay, so please come. Now you see that here this is the section called A-stable multivibrator section. It is continuous square waveform generator here. So what we are getting here? Okay, when I introduce the modulating signal here, about 500 hertz and 5 to 10 volts, in between we can vary that voltage, whereby the pulse width is varying. You can see that the bottom portion of this waveform, the width is varying. Can you see that? This pulse width. So I will show, you can show only this pulse width. Okay. So if I remove the modulating signal, see what happens. When I remove this modulating signal, the pulse carrier signal will remain constant. You can see this. See, it is. So when I introduce the modulating signal here, the pulse width is varying. Clear? Now you see that this is where we are getting the pulse width modulation. I connected to the first channel here. Clear? Now we have to convert this pulse width modulation to triggering pulses. So there is a triggering circuit here with RC, a diode and a capacitor here. So this circuit will give the triggering pulses, and the triggering pulse will introduce it to the pin number 2 of the monostable multivibrator. So monostable multivibrator will stay for on period for a particular time. That is called pulse width. It is decided by these two components, timer components called 4.7K resistor and 0.01 capacitor. So we are going to connect this as we have to connect the power supply connections for this. There is a power supply connections here. So pin number 8 and 4 is shorted, and 6 and 7 is shorted, and pin number 8 is connected to VCC, and pin number 1 is connected to ground. This is the basic connections. Now the time circuits has been connected like this. The 4.7 say is one end is connected to the VCC, another end it go to the pin number 7 or 6, and that end it should go to the capacitor, and the last the capacitor end connected to the capacitor. Now if we check the output, because the triggering pulses is connected to pin number 2, but the output is pin number 3. Now I have connected second channel to the of the CRO to the output. Now we have to get a ppm. See, this is ppm. See, this top one is a ppm. This pulse width is fixed, but I have adjusted the modulating signal frequency and amplitude such that we can see that modulating pulse width is varying, thereby pulse position of the pulse width. This width is you cannot vary, but here the width you can vary. That's why it is called as a pulse width modulation, and the pulse is fixed here, but the position is varying. That's why it is called as a pulse position modulation. So that's why this is how we have to demonstrate this. This is pulse width modulation, thereby the pulse position modulation. I think students have understand the concept of this one, pulse position modulation, and you have to measure the pulse width of this one. See, you have to measure the pulse width, for example, by adjusting these controls and adjust this and try to get a pulse width of this one. Stop this waveform so that you can measure. You adjust this and try to get a constant output here. See, like this. Try to get a constant output like this. Okay. So after adjusting a constant output, here the positions is fixed now. You can take the reading. So if you vary this and adjust this control, so now you can measure the distance of this pulse width. This pulse width, the distance multiplied with time period, you will get a pulse width modulation time period. So also measure the amplitude of this one. I think you understand that the concept of the pulse position modulation technique, and that's all. Thank you very much.